So in this lesson today for AP Statistics, we're going to look at the end of Chapter 1. So we're going to review everything that you've done in Chapter 1 and give you some problems from the textbook. So if you'll look at Chapter 1 quick summary that's on this page, basically what you're going to see is in descriptive statistics is when you're given data and asked questions about its distributions. Remember, you are usually given the summary. Sometimes you're given the summary statistics, which would be like the mean, standard deviation, and then like the 5-number summary, the minimum, Q1, median, Q3, and maximum. Other times you may be given the actual data, and then you have to go and find those summary statistics. So that's two options there. So first things that we talked about is deciding on the data type. We have two types of data. We have categorical variables. That's when we put the data into groups or categories, and that's usually written in words. And then we have quantitative variables. That's when the data takes on a numerical value where it makes sense to do operations like adding or averaging. So like if you can take the mean of something, if it's a number and you can take the mean of it or the average, then it is a quantitative variable. Plotting the data. So anytime you make a dot plot, a histogram, a box plot, a stem plot, any of those, you want to label it. Okay, so labeling it is really important. Labeling both the horizontal and the vertical axis. And again, in a dot plot, your dots go vertically if you have more than one. In a histogram, all the bars touch there. A box plot, you see you have the minimum, Q1, median, Q3, maximum. From Q1 to Q3 is called the IQR, which is the middle 50%. That's your box. You see your stem plot where you have your stems and then your leaves on the right in order. Then you could have such thing as a back-to-back stem plot, and then a bar chart. In a bar chart, there's a space in between. I remember a bar chart or a bar graph is for categorical data. The center is the mean. You can use the mean, which is the sum of all the x values divided by how many you have. You can use the median, where you're going to order the data up and then find that middle number or the average of the two middle numbers. Then the mode is the one that occurs the most often, and that's rarely used, but sometimes people will report that if there is a number that occurs a whole lot more than others. Sometimes we may make mention of it, but typically we're going to use the mean or the median. So if we look at these, this is a roughly symmetric graph. It looks like a bell shape. Again, most of the data is kind of in the middle, and then it just kind of spreads out from there. A uniform graph would be the same all the way across. So if you think about wearing a uniform, everybody's wearing the same. So it goes all the way across. This is called a bimodal graph because you see that you have a lot of data right here, and then you also have a lot of data over here. So there's two modes, so two places where the most of the data is. You have a graph that is skewed to the right, so you have your tail off to the right, and then you have a graph that is skewed to the left with a big tail off to the left. So a note, the mean gets pulled in the direction that the graph is skewed. So if it's skewed right, then the mean is going to be pulled higher towards the right. If it's skewed left, the mean is going to be pulled lower to the left. All right. So spread, the 5-number summary we talked about, is part of your spread. That's how you make a box plot. Your interquartile range is also referred to as the IQR. That is Q3 minus Q1. Your total range is the maximum minus the minimum. You have a formula for variance, and remember we did that kind of by hand when we were finding the standard deviation, but your calculator will find the standard deviation, which is square root of the variance. Remember, your calculator when you put the data into stat edit and you do stat calc number 1, it will give you the standard deviation, S. And that is the average distance that the points are from the mean. So on average, how far are the points from the mean? So the standard deviation is a number that represents the spread of the data about the mean. A smaller standard deviation would mean that you have a much smaller variability, which means everything is pretty close together. A large standard deviation, you have a much larger variability, which means things are more spread apart. And then finally, outliers. The outlier rule, to find a high outlier, you do Q3 plus 1.5 times the IQR. To find a low outlier, it should be Q1 here. So that's a small typo. So it should be Q1 minus 1.5 times the IQR. So I'll change that on there. So that would be Q1 minus 1.5 times the IQR. So again, basically what you want to do is find 1.5 times your interquartile range, and you're adding that to Q3. Anything greater than that is going to be an outlier. Take that same number you found earlier, subtract it from Q1. Anything smaller than that is going to be an outlier. The median, we know, is resistant to outliers, so it doesn't get pulled in either direction if you have an outlier, but the mean does. So the mean, remember, if it's skewed left or skewed right, the mean actually gets pulled towards the outliers. So that's why when a distribution is skewed, we like to use the median and the interquartile range. But if a distribution doesn't have any outliers and it looks pretty symmetric, we like to use the mean and the standard deviation. So that's pretty much a summary of Chapter 1, and you will have a few problems that follow to go through in your review of Chapter 1. Thanks.